Hey there, in this video we're going to learn about extraneous solutions to radical equations, which is something that we've got to watch out for anytime we're solving equations involving square roots. Now I really love this topic because at first it's going to seem very strange, but the more we think about it, it's really going to help us develop a greater understanding of the square root function and the underlying mathematics. So let's review with a quick example of a radical equation, and let's solve this equation to figure out what x equals. We can do that by first moving over any terms that are outside of our square root so that we just have a square root by itself. And when we do 3 minus 6, that gives us negative 3. Now if we want to figure out what number x equals, to get rid of this square root, we can square both sides of the equation because the square root and the square are inverse operations and they'll cancel each other out. So when we do that on this side, that cancels out the radical and we just have x equals the number that is our answer, negative 3 squared, negative 3 times itself, which is 9. So x equals 9 looks like our answer. But it turns out that in this equation, x actually does not equal 9. And if you don't believe me, let's see what happens if we check this answer by plugging it back into our original equation. If x does indeed equal 9, then when we plug 9 into the equation that we had to start with, it should all make sense. So let's plug 9 back in to our equation for x and see what this equation tells us. We have the square root of x, but we'll substitute in 9 for x since that's what x is supposed to equal. And now we want to check and see that both sides of this equation have the same value. Well, the square root of 9 is 3, and 3 plus 6 well, hang on a second. So this doesn't really seem to make sense. One side of our equation is 3 plus 6, which is supposed to equal 9, but the other side of our equation says it's equal to 3. And we know that 9 does not equal 3, so it seems like the answer that we calculated doesn't actually make sense when we plug it into our original equation. So what's going on here? Did we do some of our steps wrong? Do we need to go back and try this problem again? Well, no, in this case, it actually turns out that even though we did all of our work correctly, the issue is the equation itself cannot be solved. And in particular, this step of the problem is where the issue arises. By definition, this symbol, the principal root, is supposed to equal a positive value. But here we've written that the square root of x is equal to negative 3. And when we're using this radical symbol, the principal root, just by definition, we say that we're taking the positive answer. So it's impossible to have a situation where the principal root of x equals negative 3. Well, then why did it look like we were able to get an answer that made sense? Even though there was a negative in our problem originally, when we squared both sides of the equation, that negative ended up turning back into a positive because a negative times a negative is a positive answer. So now that we've noticed there's this issue when we square both sides of an equation, this is something that we want to watch out for in the future when we're solving radical equations. If the answer that we try to plug back into our original equation doesn't actually work, we'll say that this is a false answer. And in reality, there is no solution to this equation. So that is called an extraneous solution, this 9 that we just got here. An extraneous solution is a false answer that seems like it works if we follow all of our steps correctly at first, but we can see that the answer doesn't actually make sense if we plug it back into our original equation. So what we've just seen is that some radical equations are impossible to solve. There is no answer that will actually work. And in particular, for principal roots, an impossible situation would be something if we have the principal root of a number equal to a negative value. But when we square both sides of an equation, it makes it look like that negative turns into a positive, so it seems like there is an answer that works. So if we get an answer that is false and doesn't work in the original equation, we say that that is an extraneous solution. So I know this is all a bit technical, but the main takeaway for us is that when we're solving a radical equation, something with a square root in it, there's one last step that we're going to need to do after we solve. So let's try this example here. To solve this equation, we can first subtract 6 from both sides to get the radical part by itself. So now we would have the square root of x minus 2 equals negative 5. And already I can see that actually this equation will not work because this principal root is supposed to equal a positive number, not a negative. But let's say we didn't notice that and we continued solving. Well, then we would square both sides of our equation, and that gets rid of our radical. X minus 2 equals negative 5 squared. And now it makes it seem like this is going to turn into a positive number to give us an answer that would work. And we would get the solution x is equal to 27. So nothing about the first few steps in our problem are different, but we always need to be careful now and check our answer after we're done solving. So when we check our answer, we need to plug it back into the original equation the way that it looked before we started solving anything. Even though I know it looks like this answer works at the end, what would make it an extraneous solution is if it doesn't make the original equation true. So we're plugging 27 back into the equation where originally we had x. And now we want to simplify both sides of the equation without moving anything around in the equation. So underneath our square root, we have 27 minus 2, which gives us 25. And the square root of 25 simplifies to positive 5 because the principal root is supposed to be positive. So our equation right now says 11 is equal to 1, but of course, that doesn't make sense. So because both sides of the equation do not have the same value, we would say that this answer is false. And that means that in reality, 27 is not a real solution. 27 is an extraneous solution. It didn't actually work in the equation. So let's try solving another one. First, we need to get the square root part of this equation by itself, and we can accomplish that if we divide both sides of our equal sign by 4. So that gives us square root of x equals 40 divided by 4 is 10, And now when we square both sides to get that radical to cancel out, it looks like our final answer will be x equals 10 squared, which is 100. But since we solved this equation by squaring both sides, it's possible that we created a false extraneous solution. So we need to plug 100 back into our original equation for x and make sure that this is really true. So if we simplify the square root of 100, that gives us positive 10. And 4 times 10 is equal to 40. So both sides of our equation agree with each other. So this is true, and we would say that 100 is a valid solution. Now let's do one more just so we can continue getting some practice solving radical equations. We'll start by moving everything that is outside of this radical over to the other side of our equal sign. So if we add 7 to both sides of the equation here, then we get negative 4 times the square root of x over 2 equals 17 plus 7 gives us 24. Now the next thing we could do is divide both sides of our equation by negative 4 to get those to cancel out. And we have square root of x over 2 is equal to 24 divided by negative 4 is negative 6. Now to get rid of this square root, we should square both sides of our equation. And that leaves us with x over 2 is equal to, and negative 6 squared is positive 36. And if we want to get rid of this fraction so that we just have the variable x by itself, we can multiply both sides of our equation by 2. 2 over 2 cancels out, so that gets rid of our fraction, and it seems like our final answer is x equals 36 times 2, which is 72. But now we need to check if that answer really works. So let's plug 27 back into the original equation, the way that it looked before we started solving and messing anything around. So I'm taking the equation as it was written originally and just replacing the x that we had with our answer 72. And we'll see if this works. The first step we should do when simplifying is take care of what's inside the square root here. So 72 divided by 2 gives us 36. Then the principal root of 36 is positive 6. So we have negative 4 times 6 minus 7 equals 17. Negative 4 times positive 6 gives us negative 24. And negative 24 minus 7 gives us negative 31. So since this is not true, negative 31, of course, does not equal 17, then that means that the original answer that we had found is false. We would say that this is an extraneous solution.